All right, well, hello everyone. This is Rebecca Dallin with the City of Oklahoma City Stormwater Quality and the Central Oklahoma Stormwater Alliance. I'd like to officially welcome everyone to this very special virtual lunch and learn event. If anyone would like to receive a certificate of attendance for today's session, I think we're going to have Rob do that for us. So you can send me an email to request it, and we might be able to send them to everybody, but just go ahead and send it if you for sure want one. And if we can get those, if we can get it to everybody, we will. Um, I'll put my email address in the chat in a little bit so you'll have it handy. I did have the opportunity to hear a presentation by Rob Woodman, one of our guest speakers today at the ASCE and EWRI International Low Impact Development Conference that was in Oklahoma City last August. He had some really great information, and I thought it might be of interest to everyone. So thank you, Rob, for being willing to share your time with us today. And with that, I guess I'll let you take it away.
Yeah, thanks, Rebecca. And you're welcome. Very happy to be here. Very happy to present for everybody today. And I know, Rebecca, we had some back and forth for a while trying to come up with the optimal date, and excited for that day to have arrived. So thank you for the introduction. Again, my name is Rob Woodman. I'm a professional engineer. I was in the consulting world for about 10 years, and then the last 9 years have been more on the innovative product side of things. And the presentation that Rebecca heard me give back at the International LID conference last August, I think it was focused actually on a survey I did of about 150 civil engineers and landscape architects, trying to gather information to help educate folks, but also to help guide us a little bit as we continue to think about new widgets and gadgets and tools and solutions that we need to bring to market to hopefully solve some of the challenges that people keep coming across. And as you can imagine, cost, maintenance, space efficiency, these are some of the things that really start to have big impacts when it comes to, rolling out citywide green infrastructure, and owning a bunch of assets, and the challenges of fitting things into more urban settings. So today's presentation, I'm going to kind of lead you through all the different solutions that we generally work with: civil engineers, landscape architects, municipalities, developers. And hopefully, that you'll find those things interesting. It's going to be a fairly high-level overview. I'm also joined by my local colleague, John Warren, who is joining us remotely today. Some of you may know John as well. John is our local resource. So, when it comes to any of the products and solutions we're going to talk about today, when it comes to those, going in the ground, that interface with the contractor, with the client, making sure things are done correctly, John is a face that you will see supporting our projects locally. My role is actually more national. So I'm actually the director of our engineering and green stormwater group nationally. And so, you're going to see a smattering of things from different parts of the country as we go through today. So we'll get started. If there's any questions, you can jump in at any point. We can also put them in the chat and talk about them at the end. I'll also have a QR code at the end for the PDH certificate. That's another way to get that. But regardless of whether you feel comfortable with QR codes or not, we'll make sure that if you want a certificate, we'll get it done. I like to start with this slide, partly because I'm pretty obsessed with taking selfies, but also because what I like to kind of let folks realize is that, while we are a products and solutions company, our goal from the corporate level all the way down to where John and I work is to, be committed to the environment we're working in, right? So it's not just about selling things and getting paid. It's about helping solve problems. It's about helping leverage some of the social and community as well as environmental co-benefits that come along or are available to you when it comes to designing stormwater systems. And that's something that I'm passionate about. I've got 4 young kids, and certainly my hope is to leave the world a little bit better, or certainly no worse than it was when I started running around town. Ferguson is a large company, and I don't put this on the board to flex and say, well, look how many offices we've got for Waterworks. We've got about 33,000 associates total. But I put this on the map to say, hey, every dot on this map, well, maybe not every dot yet, but many of these dots, I've visited these places. I've met with folks, I've sat down with engineers, with municipalities, and tried to understand some of their challenges when it comes to managing wet weather on the private and the public side. And so, what I hope to do in these kind of presentations is share some of what I've learned in other parts and bring it back to you locally in a way that might, positively impact some of the ways that you're going about implementing stormwater and retrofit projects in your neck of the woods. As a starter, we do everything in that site development space. So whether it's, silt fence or dirt bags or silt sacks, TRM, so turf reinforcement mats, erosion control blankets, geogrids, fabrics, vegetated walls, scour protection, slope stability solutions, we kind of cover everything. And if we're not going to get into these things today, but if you have, any needs for these types of solutions, both myself and even more so John is a great, I guess, resource for you. And so don't hesitate to reach out. And if anything on this map's like, oh, I really want to know more about this right now, let us know and we can set up, a small 15, 30-minute call at some point to go through those things. But today we're really going to spend time in the stormwater space. And we work both in the public and the private side. And while there's a lot of similarities, both have their own unique challenges, and we try to sort of address those in the different approaches we have or the influence or leverage we have when it comes to supporting designs that we're on. We keep finding a lot of key challenges or common issues that come up, and we've kind of built our suite of solutions to address those. So space efficiency is probably the biggest one, right? We've got less and less space to work with. We're dealing with porous soils, and we've got to do more with less space. As at the same time, regulation is increasing, so we're getting more regular, more intense rain events. We're having to adjust the way we size when we think about resiliency and climate change. And we're trying to position our solutions to be helpful there. We've got to be versatile and flexible. We have to work around weird conflicts that you might find when you dig a hole in the ground. High performance, whether that's for structural or for water quality. Easy to maintain. No longer is maintenance just a nice little manual that gains a thick layer of dust on the shelf. Folks are actually having a look at what does it look like to actually not only install practices, but then deal with the ongoing cost and workforce needed to maintain and help them look good and continue to work moving forward. Cost appropriate is always important. The ability to adapt for resiliency and manage, again, some of these pieces that are coming into play now with larger storm events that we're having to manage. And then from a city scale, probably more on the private side of things, one of the challenges I've seen as I've consulted with New York City and Philly and other areas is we keep coming to this conclusion that we need better pretreatment, better screening, better way to protect our primary assets. Because when we protect those assets, we allow them to do what they were designed to do. And the focus of maintenance now becomes, simple filters and screens, which are easier, lower cost, and quicker to maintain. And if you do all three of those things, the chances of maintenance happening generally goes up. So you're going to see that smattered throughout the presentation today, this common theme of essentially voluntary pretreatment, not always regulatorily required, but a really good way to protect and keep the life cycle costs down with any kind of either subsurface or surface green infrastructure practice. So diving into it, we're going to kind of go through 5 chapters. We're going to talk about space efficient storage, filters and screens, medium biofiltration, what we call alternative surfaces or permeable or porous surfaces. And then finally, we're going to touch a little bit on what we call urban landscapes. So we're actually using soil cells to promote tree health in urban settings. On the space-efficient storage side, Ferguson is a distributor of many, many, many different products, and we're a large distributor of Waterworks products. So we get access to a lot of different systems. We work with arch chambers, large diameter pipe, concrete storage systems. But today we're going to really focus on the lower right here, the R-Tank. R-Tank is an own brand product of Ferguson's. And again, the more and more we get space constrained, the trickier some of these sites become. R-Tank becomes a more and more useful solution. And we have R-Tank systems going in across the country every day to solve issues related to stormwater storage. So the R-Tank, it's a very simple concept. So instead of using your typical pipe with stone backfill or your arch chambers with stone backfill, we're using a 95% void space module to really maximize the storage. So we're minimizing excavation, maximizing storage. And that's really the key with R-Tank. So it's that high void space, the ability to maintain traffic load ratings, which we'll talk about that in a minute, minimize excavation, maximize storage. Like I said, high void spaces allows us to keep systems shallower so we can avoid, groundwater. Our modularity, which we'll talk about in a second, allows us to work around unexpected utility conflicts in the field. But we've got different height modules, anywhere from a mini up to a single plus mini, double, triple, quad, finally up to a pent. which is essentially sort of 5 segments high. It's about 7 feet tall. And if you look at my camera, this is a miniature model. This is not the real thing. This is actually essentially a double module that I have here. And you'll see that it has a common mid plate. So when we assemble a double, it's made as one monolithic matrix of plates. We're not dealing with 2 independent pieces sliding around on top of each other. There's a few other systems out there that do that, and they've had some troubles because, if things aren't perfectly lined up, you don't transfer the load correctly, and then, you can get into a bit of a pickle. So we make them all as monolithic matrix of plates. We have different strength ratings for different cover conditions. So our heavy duty or HD, minimum of 20 inches of cover, up to 7 feet of cover. Our super duty, up to 10 feet of cover. The UD or the ultra duty only needs 12 inches of cover to be HS25 load rated, which is pretty unique. There's not a lot of systems out there that can kind of support that traffic that close to the surface. And then we finally have what's called our XD or extreme duty panel. It's a 2-inch panel that can be stacked in multiple lifts that we can use with very deep or very shallow conditions. As you can imagine, they get a little bit more expensive as you go from HD up to XD. So on projects that we're working on, we generally start with the HD. We try to see if that can work with the various site constraints and specifics. And if it doesn't, we can steadily work our way up through the range from there. Again, being a modular system, the tank's about 3 square feet in footprint. So we can work with complex shapes and kind of work in and around different obstacles, which is a really nice thing. This is a project we'll talk about a bit later, but it had some spaces left out for some deep playground equipment foundation, actually. So we're able to kind of work around that and get it done. We also have what we call maintenance modules. So if you look at my camera again, you'll see we have modules that have circular plates in them versus the standard plates that are more of a webbed kind of plate. We use these tanks at the points that pipes enter the system. So you'll see here the red line on the engineering section there, where pipes enter the system. We'll kind of wrap that row independently with fabric to trap sediment and debris or isolate it into one location, where we can, with a combination of ports at each end as well as inspection ports throughout, flush, resuspend solids, and vac them out. So that's our treatment row or our maintenance row. While we have that, I'm honestly a big fan of upstream pre-treatment for any system, whether it's pipes, chambers, tanks. It really doesn't matter. I'm yet to meet many owners or any owners on the private or public side who get super psyched about spending all their extra money on cleaning subsurface storage systems. So we find that pre-treatment's really a good place to go. And that's a trend we're seeing, especially on the public side, folks looking at smart, decentralized filters and screens just to keep that material out. And it's much easier to clean a catch basin than to be searching for material, all over subsurface systems. But we do have that circular plate as a backup should you need it. You could probably also imagine, most applications for this is stormwater detention and infiltration, depending on your soils. But we also have folks now using it in a lot of more unique or innovative ways, right? So enhancing storage under permeables, folded into linear green streetscapes, under bioretention. So instead of using, say, stone at 35 to 40% voids, we can increase that void ratio to 95% and get a lot more storage. So enhanced storage under bioretention. Combined with innovative medias, which we're going to talk a little bit about later when we get to our media and biofiltration section. And then also harvest and reuse, right? So a lot of different ways to do it. Typical section, pretty standard, 3 to 6 inch stone base, set those tanks, wrap them with a fabric. We do call for a 2-foot stone side perimeter, just so you have enough room to get in there and work that material up in lifts. There's a number of systems I see out there in their standard details. They only call for 6 inches or 12 inches. That's really not enough room to get in there with a plate compactor to build that up. So we recommend 24 inches. On some of our linear projects, we're a little bit more flexible and get down to about 12 inches, but we try to start with 24. And then again, we're wrapping tanks with fabric. So, we're a geo company, so we're not just shipping tanks to the site. We provide the tanks, the pipes, the boots, or the inspection ports, the boots, the fabric wrap, the liners, all the different parts you need. And we have recommendations for the geos depending on what your application is. So if you're doing detention, we generally use an 8-ounce non-woven. Infiltration, we'll use a woven monofilament or even a microgrid material you might see on the screen here. So like these small biaxial geogrids that we can use just to stop backfill from going into the tank, but essentially be clog proof. And then when we need an impermeable liner, we'll generally use a 30 mil PVC. We supply HDPE, LLDPE, RPE, PVC, all the different liners. but I would say 90% of the projects we ship have a PVC liner. And I think that's because PVC is pretty flexible, even in the colder months. So it's easy to work with, and you can use a specialty glue or adhesive to heat seam the seams when you're connecting parts and pieces versus needing, specialty heat guns or welding equipment to do that. Examples, parking lots, stores, hotels, sports fields, all kinds of different uses. Again, linear green streetscapes. We do a lot of work in Philly when we do small numbers of tanks in the urban right-of-way to provide volume storage. Pittsburgh's an area I've also done a bunch of work where Pittsburgh has steeper streets. So, we do a lot of terraced systems there to work with the adjacent grades. And again, I showed this image earlier with the playground, but you can see again how we can work around all these different constraints, whether it's deep tree areas, light pole bases, foundations, those types of things. We can work in and around those. More recently, we've started to be folded into a number of school-based grant retrofit projects. So we've got a number of projects going in the Milwaukee area where it's really cool projects, actually. Old, often fairly low income areas, so not the greatest neighborhoods to be part of, but taking school sites and turning their playgrounds into going from like a paved playground, basically just a bunch of pavement, to a nature-based green infrastructure rich playground, which is really fun. I think we've worked on 9 of these projects now over the last couple of years. We got another 5 this year. And it's really cool to see the way that green infrastructure isn't only helping with stormwater, but helping provide now a community amenity that really benefits the kids in these pretty rough areas. Under permeables, I mentioned before, we can fold them under permeables. If you follow what's happening in New York City, the DEP is now using a precast porous gutter line detail for a lot of their retrofit projects. We'll talk about the precast concrete later, but what's interesting in those standard details is they call for either 3 high or 5 high of our 2-inch XD panels. So it's a 6-inch section or a 10-inch section underneath those. And so it's kind of interesting to see the way those modular boxes are becoming useful, even in a urban right-of-way, like we see throughout Queens and Bronx, Flushing and whatnot, all the projects that are happening down or over in NYC. I mentioned another use, harvest and reuse. This is newer for us, but we now have a formal partnership with a company called Greater Commercial, who essentially provide a modular filtering and pump system. So we can provide the R tank to the appropriate size, line it with a PVC liner, and then work with our partners at Greater for them to design the appropriate filtering system, depending on what your use is, whether it's for irrigation or say for gray water for toilets, flushing, splash pads, whatever it may be. That can all be packaged as one system now, which is kind of a fun thing because we're seeing more and more people say, hey, look, I've got to store this stormwater. I got no ability to discharge it from the site. I need to do something with it. Or, hey, I'm super sustainably mindset. I really want to keep the water that we're generating and use it for something. Can you help? And in the past, we're like, hey, here's the R tank. You work out the rest. Now we can kind of do all that together. I mentioned when I was talking about the R tank and that treatment row with those I see a couple of comments there. Yes, splash pads. It would have to go through some, certain rigorous filtering before you'd start splashing kids with that water. But we can talk about that for sure. So I talk about the treatment row with the circular plates. We again, I think I mentioned then we kind of recommend that as backup to pre-treatment. When it comes to pre-treatment, there's a lot of devices on the market, and there's kind of 2 approaches. There's like what we would call a centralized approach or decentralized approach. Centralized is usually a larger swirl separator or a hydrodynamic separator. Decentralized is usually some kind of lower cost, simpler filter or screen that might go in each catch basin upstream of a system like our tank. And we have a whole range of them. We're not going to go through all the features and benefits of each, but whether you like screens that are down in structures, or high flow geotextile bags, or even cartridge filters for specific pollutants in the frame and grate. We work with Fabco Industries in this space. They're based out of Long Island, New York, and they've developed a bunch of really nice solutions for us. The most common device that we use with Fabco is what we call our Storm Ring CPS or connector pipe screen. This is actually a standard screening device we put with all of the drawing sets we produce for our tank designs that we're working on with engineers. We used to have a screening device that actually mounted to the wall of the structure, but we kept finding that oftentimes the wall wasn't square, it wasn't flat, it was an older drain, it was kind of hard to mount to it. But we kept finding that the pipe itself leaving a structure was generally pretty circular. So light bulb moment, why don't we mount the screen to the pipe versus the wall? And so the storm ring, the reason it's called a ring is as an expanding ring. So this ring actually gets slotted into the pipe, that's leaving, say, a structure. There's this turnbuckle in there to press that to the wall of the pipe to make it hold steady. And then we mount a kind of a triangular screen to the face, really to increase the surface area. So you're not just limiting the surface area to the circle of the pipe itself. And this is a simple device available in aluminum and stainless, and we go from 6-inch all the way to 24-inch. And if you're working with us on an R-tank design, if there's no apparent plan for upstream pretreatment and screening, you'll see this detail appear on our standard drawing sets as kind of a recommendation for like, hey, let's do something. It's not going to cost you a lot, but let's do something to make maintenance down the road simpler. Stormring will allow you to do that. And then I'd also just mention too, while we have a lot of devices, we've also found that we've needed to make specialty devices for various cities and towns that we work with. They might have a certain type of drain or a certain type of size particle they want to trap, but then another size they want to let go. And we found that every city is kind of unique. Every city-specific goals need city-specific solutions. We've developed the green inlet filter series with the Philadelphia Water Department for Philly. We've also developed the inlet screen baskets for New York City DEP for their right-of-way infiltration basins. You can see that metal basket there and some push-on pipe screens that actually go behind it. And so I put this on the board just to say, and you don't have to be a Philly or a New York to garner our time. But we realize sometimes that, we need to create something that works for you, either based again on available space or the type of screening you're trying to provide. So those kind of screens work for subsurface systems like R-tank and the like. But when it comes to surface systems, things are a little bit different. Surface systems meaning, say, like rain gardens, bioretention, biofiltration, bump outs. When we think about rain gardens and bioretention, often we think, hey, we want them to look awesome. We want them to be able to filter pollutants, so provide that water quality piece. We'd love them to be maintenance free, but nothing, unfortunately, is maintenance free. Spoiler alert, if you thought that maybe something would be maintenance free. But then we also send all this erosive velocity and sediment to these systems. And so it's a little bit tricky to really reduce the maintenance, protect these systems, right? But we found if you have pretreatment in place, it makes it a little more likely that you can achieve those upper goals. Like pretreatment traps sediment, so you're not going to smash your plants with it or coat your surface bioretention media with it. We can dissipate energy, so we're not going to blow out the plants. We're centralizing maintenance to some kind of screening pretreatment device versus having to, hand fossick for that material all throughout your bioretention system. But we kind of get into challenges because we're trying to dissipate energy and we're trying to collect sediment and debris. And if you're in a large site development site, a private site development with like a bunch of room, you can fit in a 4-bay or something nice. It's going to get the work done. Unfortunately, in the urban right-of-way with these curb line type systems, you just don't have the space to fit those practices in. And this is a real challenging point. And from, I guess, anywhere I travel, anywhere I look at BMPs or anywhere I meet with folks to talk about them, the biggest problem location for these types of practices is that curb opening, right? How can we do a better job? And I think a lot of times folks have just used, riprap or cobbles. Makes sense in theory, but then in practice, that sediment's getting bound up in there and also getting past it. So maintenance is pretty laborious because you're moving all the rocks out of the way, brooming out or vacuuming out the sediment, putting the rocks back. It can take some time. So we have 2 devices we use in this location, and these have become really popular around the country because, again, people are catching on to the fact that, I could probably do something a little bit better to protect those systems. So we have 2 units. One's called the Rain Guardian, the other one's called the Pretex. The Rain Guardian is a little precast unit. I can actually hold it up on my screen again, a little miniature model, but it has a horizontal grate on top where a lot of the trash is going to sit, and then a vertical filter wall on the backside where any sediment and finer stuff is going to be trapped before you get out. Yeah, Jacob, question? Hand was raised.
Jacob, feel free to unmute yourself and ask Rob a question.
Sorry, I think that was just a fat finger error. My bad.
Oh, no worries. All good. We'll call it a high five. That sounds good. Anyway, so these units are designed to dissipate the energy, trap the sediment, and really centralize where you do maintenance. We have one called the turret we use on the curb line. A rectangular one called the Fortress we use when the geometry doesn't make sense for the circular. And then we also have one called the Foxhole, which allows you to get behind sidewalks or under sidewalks. So this still has the horizontal grate. You can see just a little bit of it there, but it also has a solid cover up at sidewalk grade, so you get your continuing pedestrian and bikeway. Usually folks will use trench drains to get water through a sidewalk, which is great great for conveyance, but it doesn't have the filtering and screening elements. So these devices, when we started working with these 5-6 years ago, folks were like, oh, it's really interesting, but I don't think we need to do it. We'll just do some riprap. Those same folks are coming back to us now saying, actually, about that rain garden, we may want to relook at it. And I think a lot of that, again, is because pre-treatment is not often regulatorily required. And when something's not regulatorily required, often seems kind of optional for developers in particular. But then you start seeing the life cycle costs associated with curbline green infrastructure. These are really going to help with that. And I get to go out and look at a lot of our systems, both things I designed as an engineer back in my days, plus systems with these that we've helped with these days. And the systems that have that formal pretreatment of the curb line generally look a lot better. The plants are thriving; they're not being replaced. The mulch isn't completely gummed up with all kinds of sediment. The ones that don't have the pretreatment, would be kind of the opposite of that. So they really do their work. And I would argue that in one maintenance visit, you're probably going to get the return on the investment in terms of that cost differential between putting something like this in or not. Then we have the pretext, which is a deeper piece of precast. So it's just for larger watersheds. We've got a formal sump now, a suspended baffle, a weir, and a screen on the backside. So that's just for the larger watersheds. We also have found a problem area at bypass locations. So a lot of surface green infrastructure will have, will treat a certain, an inch of runoff or an inch and a half or some kind of like a 1-year event, whatever it may be. And then larger events bypass. And usually they go through some kind of internal overflow, like these domed overflows. We found that that's also the place where you get this kind of cocoon of mulch, and a lot of that sneaks through and can potentially clog small under drains or even orifice controls that exist downstream. And so we now put in high flow geotextile bags in all of our domed overflows. This is an extremely low cost item that you can retrofit existing overflows with, just so you have a place where you're going to trap that material. And while these baskets don't fill up rapidly in the course of a year, enough material accumulates in these to make me think, yeah, I'm glad this is here, because otherwise, you wouldn't be accounting for that. It would just be going somewhere downstream and potentially clogging things. So we've seen a number of cities that we work with now retroactively put these in their bump outs or even include it as a standard detail so that there's some of that protection for the bypass. On the median biofiltration side of things, we work with a company called Convergent Technologies that make a product called the Focal Point. The Focal Point is a high flow biofiltration system. We're not going to spend a ton of time here today, but if you're not familiar with high flow biofiltration, the basic idea is you're using high flow rate media. So we use 100 to 160 inch per hour media. So instead of having a large bioretention system that maybe is processing water at say 2 to 5 inches per hour, we're speeding that rate up considerably, up to 100 inches per hour or more, which allows us to justify shrinking the footprint. So the focal point is generally going to be about only 8 to 10% of the size of a typical bioretention or rain garden. We've gone through some great testing to kind of get through a number of regulatory approvals and where proprietary products need those. But the nice thing is when you have a small footprint, you have less disturbance. When you have a smaller footprint, you have less area to maintain, assuming you have good pretreatment. What I love about it, especially on the public side, is it now gives you opportunities to fold surface green infrastructure into locations that were maybe previously overlooked. So maybe you were looking at a space along the roadway and you're like, oh, a rain garden would be awesome, but based on the volume coming to it and the space available, we can only treat, say, 0.2 of an inch. Or with Focal Point, you could treat the full inch and a half in that same space. So that's a nice benefit. So you can really, again, limit disturbance and maximize performance. And that's a common theme, right? When we think about our tank, what that offers, there's some similarities there to the Focal Point. The system is a really well thought out layering of materials. So it is a vegetated system. Plants are important for the uptake of that nutrient load over time. So we require plants. We don't provide the plants. We have recommended plants and spacing for those. So they shouldn't be too overly densely planted. We want enough space between them so you can still access the surface of the media over time for any kind of maintenance. But underneath the plants, we sell the system on, and all the components are included, again, except for the plants, and it's sold on a per square foot basis. So we have 3 inches of hardwood shredded mulch, That mulch helps protect the media and also helps with plant, life. Underneath the mulch, we have 18 inches of our high performance media where we get really good removals of TSS, which is pretty obvious, but then nitrogen, phosphorus, and even bacteria, which is pretty helpful. Underneath that media, we go to a 6-inch layer of bridging stone. We provide the stone for 2 reasons. One, so it's truly clean stone, because contractors have a lot of definitions as to what clean stone actually is. And we also want to make sure we're picking at the right gradation of that stone so that the media kind of nests into the top of the stone. We're not running your typical fabrics through these systems because those have become a known source of clogging. So we've eliminated those standard geos and we're just bridging, going from the media to the stone. Underneath the stone, we do have a layer of microgrid, that green mesh I held up on my camera before. You can see that's a very open material. You can see me right through it. Hello. And the point of that is just to stop the stone from falling down into our modular underdrain. So we actually use the R tank as our underdrain. 2 reasons for that. One, we get this high flow rate coming through the media. We want a high void efficient underdrain to be able to take that flow and send it on if we're doing what we would say just treat and release, so just water quality and sending it on. But knowing what you know about our tank being traffic load rated, and we have all these different height modules, we can come through this small footprint at the surface for water quality. That gives us water quality, not a lot of internal storage for volume control or water quantity, but then after treatment, we can expand our R tank out over a much smaller footprint. So instead of bioretention or rain gardens taking up that entire surface, or let's say real estate area, you can't do much else in the space, we have these smaller focal points drop down and they can replicate that, what would have been surface storage, subsurface. Now, obviously, subsurface storage is always more expensive than surface storage, but when you're space limited and you're trying to maximize your parking or minimize your disturbance, you can do a lot of good work with focal point. Again, you'll see this project here. This was a little LID park we did in my backyard here, but the little green blobs are the focal points. That's all you see at the surface. Nice little planted, space efficient micro practices. But underneath each of those focal points has its own storage system in the form of our tank. So it's kind of a cool way. Oftentimes we think about water quality here and water quality there, and we're not kind of combining the two. But with focal point, we're kind of putting one over the other and can get it done. Now, not all the projects we work on are like that. Some are just a bunch of focal points around the site, and then they're piped to one central system. Maybe it's chambers, maybe it's our tank, maybe it's a dry pond. Awesome. Other projects, depending on how things are laying out and how the modeling is working, each focal point has its own independent storage, sometimes with its own independent outlet controls as well. So again, a lot of versatility, not taking up a lot of space at the surface. It's also boxless as well. So everything comes in components to the site. So you don't need to buy an expensive concrete box. You also have a lot of flexibility with the shape. It doesn't have to be a perfect rectangle, as much as a lot of civil engineers I know love a good 90-degree corner and a nice rectangular shape. You can be more creative if you want to be daring. But everything comes in components, pre-mixed and certified. Dig a hole, line the sides with a basic fabric, place the R tank, wrap it with a microgrid, bring over a bridging bag of bridging stone, place that in the hole at 6-inch depth, 18 inches of media. And then finally, we'll temporarily cover it with fabric just until everything upstream that's feeding it is stable. Pavement's down, slopes are established. Once that's done, we take the fabric away permanently and place the plants in the mulch. And then the system is active and ready to receive runoff. So it's a very straightforward process. We put ourselves out in the field for all of the installation so it gets done right. I won't get a ton into sizing right now, just for sake of time, but the important thing to know is that we only need 174 square feet of focal point for every acre of tributary area. So if you think about an acre of parking or an acre of pavement, that's going to basically one parking space worth of focal point. So very small footprint. We model it through to make sure that we're actually demonstrating, at least over 24-hour distribution, that the water quality volume is treated prior to bypass, essentially dynamically modeling that flow throughout the storm event. That's for treatment. And then obviously, again, when it comes to the volume piece, whether it's for infiltration or channel protection or managed release, detention, peak flow attenuation, we can expand the R tank out again over a larger footprint and get it done. If you're curious about the system, or if you have a project, you want to talk more about how we model it and how we size it, be more than happy to connect and go through that. But I think the takeaway is it's nature-based green infrastructure and a much smaller footprint, which allows you, especially in retrofit applications, to just fit those things in easier. Sometimes folks have the goal of phosphorus, so they need something like with a media. Sometimes they don't, it's just TSS, but you're trying to leverage like the community and social impact. So having something at the surface that you can put an educational placard near or something like that is going to help create a connection from the public to the work you're doing. And when you do that, then it's sometimes easy to get support and funding for future projects. So there's different approaches to why something like this will make sense. But again, at the end of the day, it's small footprint. This is a 33 square foot focal point, which treats this entire roof area of this apartment building. And there's actually R-tank doubles underneath all of this concrete amenity space for stormwater storage. You can kind of see that from the bird's eye view there. So a lot of different ways to fold it in. This one isn't the most attractive looking focal point, but it's a pretty cool project. If you look at the plan view here, essentially the treated and the bypass, so it comes through, runoff comes off these pavers, goes through the rain guardian, gets treated, then enters these R tanks, or the bypass also enters the R tanks. But those R tanks are back underneath the paver drive area, right? So again, minimizing that loss of space at the surface, but in this case, still meeting phosphorus law as well as providing detention. We're at the ASCE headquarters. I worked on this project with ASCE, great little project, kind of walking the talk and retrofitting the lot with a bunch of different practices, including a nice rectangular focal point. Roadway projects. This has become something that I really personally invested in 3 or 4 years ago. I'm like, hey, I'm sick of seeing these green practices just look terrible after a winter or look terrible after a year or two. What's the missing piece? And kept finding that, that combination of pre-treatment, which you'll see in all of these examples, is really clutch in terms of, again, protecting the plants, minimizing how often you have to replace mulch. And now you really just focus your maintenance on this location. And then more and more the term Rain Guardian, the name of that product, a little cheesy, but it's starting to make more sense because it's really, protecting, it's providing that first line of defense, guarding the practice behind it. And when you put that in place, the feasibility of folding green infrastructure, sustainable green infrastructure into linear tight spaces becomes a lot more feasible. On the urban landscape side of things, one of the biggest challenges we see with projects is that, folks are looking to get nice big trees like this. Provide that shade, provide the cooling, provide interception, uptake, mental health benefits, aesthetics, all the things that come along with a good urban tree. Unfortunately, many of us see trees down the street that look something like this, or something that many years after install look like that. And as calling myself out as a civil engineer, I think as civils, we don't do a great job accommodating for these. Dig a hole, throw a root ball in it, pack some soil around it, and hope that things will be good. Well, trees need a certain volume of soil. And I know in Oklahoma City, there's been a number of applications of soil cells. We have a product called the City Green Stratavolt. This is a product that, similar to like the Deep Root Silver Cell, you may have heard of that product before. Essentially what we're doing is using a plastic module to be our structural element to hold up the sidewalk, the pavers, the esplanade area above. But then within that structure, we're able to place deep, rich, loose, or uncompacted planting soil in a volume suitable for that tree to thrive. So we're kind of restoring some of that nature's subsurface, but not compromising the integrity of the surface above it, right? Historically, we'd see roots busting out of sidewalks or, areas where we put soil and now we've got sags and potholes and things like that. We can avoid that with this approach, but again, still provide an environment where a tree could get its, required 1,000 cubic foot, 15 cubic feet of soil, but in more of an urban setting. And it's been fun for me to look at these too. It seems like all the conferences I go to, and this including the LID conference where Rebecca and I met last year, I feel like every case study we see now includes some kind of soil cell element to the project. I think trees are starting to become more valued, and I think the value that trees play in the stormwater space is becoming more understood as well. Now, trees aren't necessarily yet kind of part of the regulatory landscape from stormwater, but with their affinity for water, with their affinity for that nutrient load, we're seeing those two parts now start to collide a little bit more, and seeing more trees and trees valued more in some of these linear streetscape projects. So the nice thing is, and I didn't mention it earlier, but with focal point, it's a fairly sandy, stony media. Actually, I have a jar here on my shelf, so I don't know if you can see on the camera here, but it's not the kind of stuff you'd be wanting to plant your vegetables in necessarily, nor would you necessarily plant a tree in it. And so with a focal point, we generally do smaller like perennial grasses and other plants like that. Because trees, it's a sandy, stony mix. Trees aren't going to thrive in that. So we usually put the smaller plants there. But then, when it comes to tree cells, that's a great place, obviously, for trees, probably why it's called a tree cell. But we've started to dabble with some combo details now where we're using a curb inlet, go through a rain guardian, enter a focal point with some of the smaller plantings, filter down, but then have that filtered water actually enter a stratovolt system either side or around it, where we're now providing some irrigation to the tree. So try to come up with ways to combine those pieces and have the two support each other. Anyway, so that's that. Module heights, our tank, again, we go from 9 inches up to 7 feet. With stratovolt, we go from about 17 inches up to about 4.5 feet. And that's really just because that 2 to 4 foot height range is sort of that pretty optimal depth range for the tree root system. That's really where they want to go, not too much deeper and not too much shallower. So we're kind of capitalizing on that sweet spot for the tree roots. So that's that. And then finally, alternative surfaces. So we have a number of permeable and porous surfaces. All of the permeables that I work with are really geared to having a better story when it comes to life cycle costs. I think some of the early generation, whether it's porous asphalt, cast in place, porous concrete, pavers with like chipstone infill, have had some challenges when it comes to the conversation around maintenance and the efficacy of it and also the frequency of it. So Powerblock, which is an own brand product for us, is an open joint permeable paver. So it's a solid concrete, precast concrete block. The block itself is not porous, but it has an open 1/4 inch space around the block. And if you look, this is a 3D printed model, but you'll notice on the sides we have these spaces built into the block. So we have these 1/4 inch spaces so that the blocks can't get too far apart nor get too close together to maintain that 1/4 inch space. But with that open 1/4 inch space, we're not putting any aggregate infill in there, not any of that chipstone in there. While that often happens with permeables, that's the place where a lot of like sediment and silts will gather and kind of clog at the surface. So maintenance, you're having to remove all that sediment and the stone and then put new stone back. With an open joint, maintenance is really a one-step process. From time to time, you're going to spray and suck and get out that accumulated sediment in the open spaces and restore it to its original performance. So our conveyance rates are kind of meaninglessly, stupidly high in some extent. Like the idea that you would need to work at 1,000 inches per hour means you've probably got quite a storm event on your hands. But we're rapidly conveying that runoff through the surface. So you're not going to get the run-on that you get from other kind of surfaces or paved surfaces. High conveyance rates, we could use our tank in there. In a lot of states that need water quality, they'll add a sand filter or a mineral course in there for filtration. But the real win is those low life cycle costs. You're not going to maintain this anywhere near as frequently as you would a typical surface, a permeable surface. And when you do it, it's simpler and quicker. And so we're finding, especially on the municipal side, the open joint system making a lot of sense to folks who are obviously considerate of life cycle costs. It supports traffic load rating. The block is actually 4.5 inches tall, so it's a nice beefy block. So it's suitable for commercial, ADA compliant. Hand place it. It's available in colors. That's not a coating to the block. That's actually a color that's mixed into the paver itself or into the concrete itself. And again, a lot of folks say, hey, I don't need to use power block everywhere. Let's put it in strategic locations. Maybe we'll use regular pavement in the drive aisles and the permeables in the spaces. So that's kind of what you're looking at for power block. As an alternative to power block, and maybe less so for parking spaces, more so for municipal gutter lines, we work with Stormcrete, which is a precast porous concrete panel that's used throughout the country. But it was really developed to overcome a lot of the challenges folks have had with, either casting in place porous concrete, right? When you cast in place porous concrete, conditions have got to be a certain way. You got to have the right mix design. You need the right QA/QC in the field. How do you place it? How do you reinforce it? How do you densify it? How do you protect it and cure it after it's placed? People have had their challenges with that. So Stormcrete kind of takes a lot of that guesswork out. It's made in a controlled environment, so it's consistent, repeatable, panel to panel. So you get that consistent performance, no worries about the field conditions. You can pretty much place it any time of the year. It also has hidden lifting points, so it's easy to place. And then it's also easy actually to pick up. So if you had to access your utility under there, or you had a panel that cracked because the subgrade was poor, you had to replace it, or even you had a panel that was completely clogged with sediment and you couldn't restore it from the surface, you could pick it up, turn it on its side, pressure wash both sides, and try to restore that open or those pathways or the pores through the system. So it's really nifty. Again, you can see the kind of applications, gutter lines. It's a 2-foot wide or a 4-foot wide panel. Here's a 2-foot example out in California. Again, you can see those lifting points being used to place it in place. And like I touched on earlier, New York City is now using this Stormcrete product for miles and miles of porous gutter lines or right-of-way gutter lines. And underneath that gutter line is our XD panel, either 3 panels high when it's 2 feet wide, or when it's 4 feet wide, Stormcrete, it's 5 panels high. So trying to keep everything super shallow with the goal of trying to not conflict with utility service stubs and things like that. And then the last product in that family is the EcoRaster. So EcoRaster is our grass and gravel solution, or a plastic grid system. I'll be honest, there's a lot of products in this space. The only one that we really promote to folks is this EcoRaster product. It's made with low density polyethylene. So it's a little more flexible and a little less brittle in the colder months. You'll see here it's like a 13-inch square. It's even listed on the table here, but it comes pre-assembled in 3 panels by 4 long. So you're sliding about 14 square feet off at a time. So it's a nice large panel, means installation is very rapid. We have the highest field strength on the market, which is good too. So we can handle some really extreme loads. It's going to stay where it needs to go. And we have 2 thicknesses we work with. The E40, which is our all-around product, which is 1.6 inches tall, and then a little bit thicker, with a slightly thicker wall thickness, is the E50 that we use for heavy duty applications. It's a great little system, easy to get together, very difficult to get apart. Most of the time we're using E40 for our emergency access lanes, fire lanes, things like that, parking areas, drives, paths, trails, et cetera, et cetera. E50 we kind of reserve for true roadways, industrial heavy trucking, where you're getting almost all trucks coming in for that, places to park and offload, as well as military and things like that. So 2 great little solutions there. There's also a paver product in that family. It's a little bit redundant with Power Block, but this is called the Blocks. It has a drainage channel around all 4 sides, and it seats 4 concrete pavers, but it perfectly matches up size and shape with the E50. So you can do some really interesting layouts if you like doing Legos as big kids, or kind of want to mix like the hardscape with the softerscape. And being concrete pavers, you can use different colored pavers as your lane like markings and things like that versus typical paint. So cool little system there. If you want to put it all together, you can see a few examples of ways we've put both E40 for hand carry canoe launches to blocks in parking lots, worked with radiuses with the E40. And in Ann Arbor, Michigan right now, I'm working on a project with a really interesting developer called Thrive Collaborative, who are doing a highly sustainable development where, net zero everything and really trying to minimize their carbon footprint and address any kind of carbon offsets. So the only concrete being used in this project is in the foundations of the building, and unfortunately one road that had to get put in before we finished our approvals. But we were actually able to get approval from City of Ann Arbor, both fire and utilities and all the different groups there, to use stone-filled EcoRaster E50 as our roadways instead of asphalt or concrete. And you can imagine that was quite a process to get through on the planning board side of things, because a lot of folks are just very comfortable with concrete and asphalt. And the idea of a gravel surface just sounds very ruttable over time. Obviously, with the EcoRaster, we're confining that material, and we don't have the same ruttability issues. And interestingly, we actually used it temporarily for concrete truck access, and then they picked it up, hosed it down, and used it to place in the roads. This will be further along this spring, and they're actually using different color aggregates to help delineate crosswalks and things like that too. And then the last thing I'll just touch on, just as a teaser again, we do a full set of engineered erosion solutions. So cellular confinement, vegetated walls, vegetated slopes, alternatives at like where water meets the land in terms of scour protection, or vegetated alternatives to riprap, different ways to do more softer nature-based outfall locations. We got a lot of different things in that category. And again, if you need any information, reach out to John and I, and we can we can certainly help you. And then just last couple of slides. Again, this is not about like, hey, we got a bunch of products, I hope you use them, or I hope you recommend people to use them. We've got a great engineering team that I've been able to kind of build as part of the structure I lead at Ferguson. So we have a great team of engineering designers. For every project we're working on, we create custom site-specific layouts, overlays, detail sets for your use. We're familiar with most of the different modeling softwares. We can help there. We can produce what we call sketchbooks, just early vision casting. If you've got a part of town, you're like, oh, we really want to do GI here, not really sure what we could accommodate, we'd be happy to go walk it, come up with some ideas for you and share that with you in the form of a sketchbook. Probably the most important thing that we do is participate in construction oversight. Not full-time unless it's required, but we do our own pre-construction meetings for all of our products that go in the ground on the engineered product side of things. This is probably the most important thing that happens, and maybe one of the things that differentiates us from some of our competition. I think, you can have the greatest product in the world, the greatest plans in the world, the greatest design team in the world, even a really good contractor. But if that communication gets broken between the design and the contractor, and things just sort of go in haphazardly, or maybe the contractor taking some guesses, that's when things don't go well. So we pride ourselves on having pre-construction meetings. We'll visit the site during construction and help with any kind of closeout. And then tying back to my first slide about kind of being passionate about the environment that we're helping protect. We're not just a transactional business. If you need help with, maintenance training or education, or, you want to help build educational placards or some kind of program, PR event, press event around something you're doing in this space. These are the sorts of things that Ferguson is definitely committed to and interested in. And if there's ways that we can be helpful to you with some of your programming and other things you're doing, we'd be more than happy to have a conversation and see if we can help. So that's me when I do my hair a certain way. Obviously, I don't quite look like that today, but certainly appreciate the time. And Rebecca, thanks again for setting this up. I mentioned at the beginning, there is a QR code here. If you want to scan that to sign up for a PDH certificate. If that's too confusing or complicated, we'll also make sure a link goes out. And while I do that, Sarah, I see you have your hand up, and I'm also going to check the chat box.
Yes. Okay. I'm working with two devices here, so sorry if that's kind of wonky.
No, you're fine.
So I work in the Office of Sustainability at the City of Oklahoma City. We have very low capacity, and we do not do operations and maintenance. However, we're very interested in and are recommending these green infrastructure projects in other places. So my question is, how do you or what guidance could you provide to a position like mine, where we're convincing or trying to encourage other departments that are responsible for that O&M after it gets put in, that this green infrastructure is a good option, especially when they've had some challenges with some like older generations of projects or products. Your cost estimates or case studies with cost estimates that show that you can tailor it to a local condition, because we can advocate all day long, but it's difficult for us to say, because we don't do operations, we don't do maintenance.
Cool.
We're more of an intermediary, introducing departments and funders and things like that to opportunities. So
yeah, great comments and questions. And it is tricky, and I talk to folks all the time in similar boats. Every so often you kind of find the rare ones where like Philadelphia Water Department, very established operation and maintenance team as part of the same organization that has their design and implementation team, right? So it makes sense that they do pretty well with that. They didn't get it right to start with, though. I think it took a few years to work out, oh, hold on, we own all these assets, what are we going to do with them? But a lot of the conversations I've had, whether it's even with Philly, but even smaller municipalities and towns, is really emphasizing the pre-treatment part. I think that's something that really helps get some groups on board, because when you think about a lot of maintenance crews, they want to clean catch basins. That's what they're good at doing. They can pop covers, they can bring their hose up, whether it's a clamshell or a hose, and they can suck that material out. So when it comes to like the pre-treatment part, we've tried to either create things or bring things in that kind of look a little bit like that. So the idea that you could just pull up, clean it, and move on. Obviously, with any kind of garden of sorts, rain garden things, just like a garden at home, there's going to be some weeds. There's going to be some of that to deal with. But if you're not having to deal with, more complex extraction of sediment loads, I think that helps. So, I think for those in the past who said, "Oh, green infrastructure, we really have a hard time with it." Like, hey, I get it. Nowadays there's other things we can put in place to try to simplify that maintenance effort. That doesn't necessarily convince everybody, and we all sail off into the sunset saying, let's, build green infrastructure everywhere. But I think it gets us closer there, and it's a common trend. Like everywhere we go, my consulting with cities is more around pre-treatment than it is the actual assets itself. And I think there's something to note from that. And at any point, Sarah, like if there was if you wanted us to share some of that learning in a very non-aggressive way, be more than happy to do that. And potentially connect you with folks that we know in other cities that could speak a little less biasly about like how they've sort of adapted and enhanced their drawings over time or the details to perform better.
Perfect. Yeah, that would be great. I appreciate it very much. Thank you.
Yeah, reach out to me. That'd be great.
Okay, cool deal.
Yeah, and Rebecca, I saw your request for the slides. We will definitely get you the slides so that you can share them with everybody, no problems.
Perfect. Thank you.
Anybody else?
It looks like Josh in Tulsa, Oklahoma had a question. Says, sorry, you may have mentioned it earlier. Do you have any products that have been installed in the Tulsa area?
Mr. Warren, any thoughts there?
Not yet. Not yet. No, we've only been, I've only been in this position for right around a year, just a little over a year. So the answer is no, but we're looking for the first one. How's that?
Yeah, no, good answer. And I think, yeah, good point, John. I mean, a lot of this initiative that I get to lead, really, it started on the East Coast. We started to wrap around through Texas, Louisiana. We started to grow up through California, Arizona. We got a little bit in the Great Lakes, and continuing to build out our team, not only folks like John on the ground, but then also some of our engineered product specialists too. So yeah, if there are opportunities to pilot something or a project where you're like, oh, this would be interesting, we'd be more than happy to, discuss that and, come up with a way to make it a win-win for both sides.
Great. A few people have requested certificates of attendance, so I went ahead and just sent that link from that QR code to them. So hopefully they'll get that filled out for you. But if not, I can get you a list of attendees, and John. So.
Okay, great. Thank you for doing that. And I see you copied our contact information there too. So awesome. Yeah, and we'd love to have further conversation. Again, obviously, we have a number of different products and solutions. The hope is we have something that's interesting or worth considering on projects. We also realize that there's traditional practices, which are always a good place to start, and there's other companies that rep different things too. And there's enough work out there for everybody. But our hope is to be helpful, even in that concept level phase. We are very comfortable with where our pricing is. So if you have questions around what a particular unit costs or, those types of things, we can get back to you very quickly on that stuff. So you can kind of see how that fits into your budgets too. So yeah, the hope is to be a resource between John and myself. And, if there's any further conversation or any other products that there's curiosity around that we kind of just put up on the board briefly, we can, have smaller group further conversations on those.
Great. Well, thanks again so much. I appreciate your time today, and thank you so much to everyone for joining us. We're going to put a recording of this on our COSWA, Central Oklahoma Stormwater Alliance YouTube page. And I've posted a link to that in the chat. And then we've also, once we get those slides, we will put those on our website. And I put that link in the chat as well. I can send out a follow-up email to people to try to get that information out there. But anyway, thank you again.